Hello, Luke. Welcome to lesson 101. So today I thought I would change things up a little bit, and as you've noticed visually, things look a little bit different today. I thought I'd go with kind of a blackboard background and, the same colors I'll be using for the actual writing, but you'll have to let me know what you think. If you like this over the whiteboard, and if so, I can continue to do them using the black background. Otherwise, if you like the white, we can do that too. Or if you don't really care, that's fine as well. But I thought I'd give it a try and get some feedback from you. So anyway, getting on to the lesson here. Today we'll be looking at factorable denominators. Really, it's mostly just review today. They're just kind of giving us some more complicated problems in which we get to use our factoring skills in order to add. All right, so basically what they'll do is they'll give you two expressions like this, two terms, and they'll say add these two terms together. And at first glance, it looks like it'd be kind of complicated because you would be looking at this and you'd say, well, I need to find a common denominator, right, in order to add these. And how do I do that? Because this is a trinomial, so I guess, I could put that in parentheses if I wanted, just to kind of show that that's a one group, right? And then I have over here an x minus 4. So is my common denominator, x minus 4 times x squared minus x minus 12, just kind of combining these two. Would that be the common denominator? Well, sometimes it will be, but in these algebra textbooks, they'll often allow these problems, or they're kind of, they'll design these problems so that you can actually simplify them a bit through factoring and make the addition and finding the common denominator a bit easier. So general rule here is going to be just to take the denominators, and before you find the common denominator, just factor them as much as you are able to. So let's go ahead and do that right now. So let's take this first denominator here and we'll factor it out. Now, if we look at this, we can say, oh, it's a trinomial, and it's in the form x squared, and then minus an x term, and then minus some other non-variable term. And that should look familiar. A lot of times we can factor this into a set of binomials. So let's try that. So we would end up with x. This minus tells us that we have opposite signs. The 12, if we kind of think of the factors of 12, somehow we have to get to a 1. Well, a 4 and 3 are factors of 12, and they could combine to give us a 1. And the 4 is going to go with the larger, or the negative sign is going to go with the larger number, which is the 4. And then we have the 3. So there we have it. So we've factored the denominator. Now, clearly in this next expression here, there's nothing we can do in the denominator. It's already factored. I'm going to leave it in parentheses just to remind us that this is a one item here, one sum term, all right? One factor, I guess I should say, one factor of the denominator. All right, so once we have it in this form, now we can look at it and maybe things will become a little bit more clear here. Because now we can see that, okay, if I'm trying to find a common denominator here, now there is something that is, is common between these two denominators. I have an x minus 4 over here, and I have an x minus 4 over here. So that factor, is common to the two terms. So therefore, if I'm going to rewrite these fractions with a common denominator, and then I'll subtract them, what's the common denominator? Well, this first fraction has a factor of x minus 4, and it has a factor x plus 3. Those are the two factors, okay? This has an x minus 4. So we need to have all the factors in our common denominator, so we need an x minus 4. All right, and if we put that in here, that essentially means, okay, we've covered our ground, our bases for this x minus 4 and this x minus 4. They're both accounted for in this common denominator. I still need to account for the x plus 3, so that needs to be in the common denominator as well. And there we go. That's kind of accounting for all of our factors. All right. And so that means our common denominator over here will also be x minus 4, x plus 3. All right. Common denominator. And then we can figure out our numerators. So we have a 6x. That's not going to change. But we need to multiply that by whatever is, whatever is not in this. Well, I should say whatever is not in here when we compare it to here. So in this case, we have an x minus 4, x plus 3. Well, that's everything in here. So all we multiplied this by was a 1 over a 1, right? To get to this term, or this fraction here. So there you go. So we really don't do anything with that one. He just stays 6x. Over here, what did we multiply this fraction by to get to this? Well, we would have had to have multiplied this denominator by an x plus 3, right? In order to get to this denominator. So we need to do the same thing in the numerator. We need to multiply that by an x plus 3. So we end up with p times x plus 3 in the numerator. Okay? And then finally, we can just rewrite this maybe a little neater by just placing everything over our common denominator, which is x minus 4 times x plus 3. And then in the numerator, we have the 6x. Don't forget this minus here. So it's minus the p times the x plus 3. Okay? And then finally, we could, technically this is, you could leave it like this, I suppose. If you wanted to take it one step further, you could remultiply everything out to kind of put it back into the form that it started in. And if we were to do that, we'd have 6x, and then we'd have to multiply this p through the parentheses. So we'd have a negative px negative 3p all over, and then we can multiply this out with FOIL, but we really know that it is going to be the x squared, excuse me, minus x minus 12. You could get that with your FOIL. And there you go. That would be maybe our final answer. And again, this is acceptable. It's just not all the way expanded, which is fine. Sometimes this is more desirable. So I'll really accept it either way. But in this case, they started it out all expanded, so I finished it all expanded. Okay? All right, so let's try another one here. You can see this is pretty much review. It's just factoring the denominator before you find the common denominator. So go ahead and try this one on your own. And then when you're done, unpause the video and we'll try it together. All right, so let's see how you did. So we have, for the first fraction, if we factor it out, break up that denominator, we can see again, this is a trinomial that hopefully we can get into a set of binomials here. So the x is going to divide out here. 6 is going to be a 5 and a 1. Minus means we're going to have opposite signs, and this minus is going to go with the bigger number. So we have this. All right. And then over here, we have a 5 over. Now here, what can I do? I can factor out an x, right? Factor out an x, and I have an x minus 6 left over. All right. So if I do that, now I can look at this and say, okay, so what is my common denominator here? Oh, and actually, I'm sorry. I made a mistake. This should be a 6. Maybe you caught that. This should be a 6, right? Because factors of a 6 would be 6 and a 1. Yeah, should be a 6. There we go. All right. So, yeah, it wasn't turning out as easy as it should there for a second. So now we know. All right, so we have our denominators all factored out. Now, what should we do? We should look for what's common, right? Let's find our common denominator. So again, we'll divide it into first. We'll first place it in two fractions here. So what's the denominator? Well, we have an x plus 1 as a factor, x minus 6 as a factor. That's shared with this one over here. And then we have an x. So maybe I'll start with, I know I have an x, right? And that accounts for this one. Then I have an x plus 1. That's another factor that has to be in there, and that accounts for this one. And then I have an x minus 6. And the x minus 6 is going to account for this one as well as this one. Right? So there, I have everything accounted for. This is going to be my common denominator, so it's going to be in both. All right, but now I need to find out what the numerator would be. So I have a 7, and I'm going to be multiplying that by, what did I have to multiply this denominator by? Well, I have the x plus 1, and I have the x minus 6, so I'd have to multiply this by an x to get to this new denominator. So I need to multiply the 7 by an x. This one here, I have an x and an x minus 6, so I'd have to multiply this by an x plus 1 to get to this new denominator. So I have to multiply the numerator by the x plus 1. There we go. So the hard part is done. Now we will just rewrite this, maybe just expanding it a bit. So, and putting it over one denominator. So the one denominator is going to be the x plus 1, x minus 6. I might just leave it like this. This is kind of nasty to expand, so I'm going to leave it the way it is. All right, and then up in the numerator, I have 7 times x. Well, that's 7x. Then I have minus the 5x minus 5. Don't forget to distribute that negative all the way through. It's a negative 5 times x, which would be a negative 5x, and then a negative 5 again times the positive 1 gives us the negative 5. All right, so there we go. That'll be my solution. So I kind of expanded the top. It was pretty easy to do. The bottom, well, I have kind of some FOIL I could do here, but then I'd have to multiply an x through it. It's kind of messy. I'm just going to leave it the way it is. So there we go. That would be my final answer. All right, let's try one more here and see how you do. And then I think you're ready to attack your seat work and get started with that today. So pause the video, try this one on your own, and then we'll do it together. All right, so let's see how you did. Let's see, what color should we go with here? So we have our denominators that we are trying to factor. So this one, x squared plus x minus 6, let's factor that out. So we'll have an x and an x. The 6 would break down into a 3 and a 2. And this minus means they're going to be different signs. The plus is going to be with the larger one. So plus here, minus here. There we go. And then over here, I can factor out an x and be left with an x plus 3. In the numerators, I still have 4x plus 2 and a 4. All right, so now let's combine these. Let's find a common denominator. So the common denominator, and I'm actually just going to, well, all right, we'll do it the same way we've been doing it. I thought about combining it into one fraction right away, but we'll keep doing the same steps here. All right, so what's our common denominator? Well, we need an x plus 3, so we'll put him in there. And that takes care of this one and takes care of this one. We need an x minus 2. Put him in there. That takes care of this one. But I still need an x, so I'm going to put him out in front. So there is my common denominator, which means it's going to be used on this fraction as well. Okay, now I can look at the numerator. So I have a 4x plus 2. Now watch out, because I'm going to multiply this by something. So because this is a sum, which we haven't had in the previous problems, I'm going to right away put this into parentheses to remind myself that this is kind of one entity. We need to multiply everything, or multiply every term in this 4x plus 2 by whatever we need to get to the common denominator. So right away, put that in parentheses so that we get that straight. So in the denominator, we have x plus 3, x minus 2. All that's missing is the x. So we're going to multiply this by an x. And notice again, it's not just the 2 times the x, it's the whole 4x plus 2 times the x. All right. Okay, and then over here, we have an x and an x plus 3, x and an x plus 3, so we need the x minus 2. in the numerator. So 4 times x minus 2. Okay? All right. And then we can just combine these into one nice fraction here, which is x plus 3, x minus 2. Here's my common denominator. And let's multiply some of this out a little bit. So this is going to give us 4x squared plus 2x, right? And then over here, I'm going to have a negative 4. Don't forget to bring that negative up. Negative 4 times x is going to be a negative 4x. Negative 4 times a negative 2 is going to be a positive 8, right? Now, the one benefit here about, the one benefit to expanding the numerators here is now I actually have a couple of like terms that I can play with here. This is actually going to equal, I should have said this is equal and this is equal. This is going to equal the 4x squared, but now I've got a 2x and a negative 4x. I can combine those, and that's going to give me a negative 2x plus 8. And then I can, in the denominators, show my x plus 3, x minus 2. Minus 2. Right? Very good. So there you go. I think that's going to be our final answer to this one right here. Okay, so hopefully this makes sense. Again, there's really nothing new. It's just practicing our factoring and really practicing our common denominator rules. So I think we'll stop here. Good luck with the seed work, and I will see you tomorrow. And let me know what you think of this new blackboard. I actually kind of like it. I feel like the colors pop a little bit more, but maybe that's just me. All right, well, we'll talk to you later, and good luck.